This video is the second of 3 tutorials that I'm making on first array lists, which I've just completed. This one is about set tutorials, and then the last one will be about maps. And I'm not going to show you the basics of how to use maps. I'll try to link in my video up here, which is a lecture on how to use sets. But assuming that you've done the basic problems and that you've looked and practiced it and done some problems there. Unfortunately, Practice It really doesn't have a lot of set problems, so it'll be good to see a couple more set problems here. These will be a little bit more advanced. So I've got a function here called remove odd. So we've got an input set here, and I've got an example here. This shows it as ordered, but sets, of course, are unordered. So there's just 1, 2, 3, 4, 5 in there somehow. And we want to remove all the odd numbers, so that's going to be 1, 3, and 5. So after we're done here, we should have just the 2 and 4. So the basic algorithm is we're just going to go through the set. Now, unfortunately, you can't use a for loop indexing into the set. There's no get for sets. So you're going to need to use an iterator, which is great because it's good to know how to use iterators. You can use iterators on any Java collection. So you're going to have to use an iterator, and it will give you some element of the set. If it's a hash set, it could be in any order. And then you have to check each one to see if it's odd. If whatever they give you back is odd, you want to remove it from the set. So first I want you to write some pseudocode. So I want you to stop the video and write that out. Hopefully by now you've done that. So let's take a look at what that pseudocode is. So for each element in the set, if it's odd, then we're going to want to remove it. And now hopefully you will stop the video and you will go and write your own code as well. Assuming that you've done that, let's move on. So again, we can't do a for each loop. So because we're going to be we're going to actually have to look at the iterator for the set. And so we're going to use a while loop while it has next, just like a scanner. We've got to get the value, and if that value is odd, then we can finally remove it. So go ahead and run that code. So we've got the 1, 2, 3, 4, 5, and afterwards it is 2 and 4. I have one more example for you. I call this one make even. It takes a set, and here as an example that it's looking unordered. So we have a set, and what I want to do is I want to make each of these even by rounding up, by adding 1. So for the 19, it gets transferred to 20. 4 remains. 7 gets rounded up to 8. 9 gets rounded up to 10. 12 is fine. 13 goes up to 14. And there's no way to set an item in a set. There's no put, there's no set. So you have to just remove an item and then add another one. So the position of all these items is purely coincidental because sets are not necessarily ordered. So I want you to write some pseudocode. So you're going to have to look through each element in the set. And we just showed you how you can iterate through the set. So you're going to look at each element. You're going to check to see if it's odd. And if it's odd, you're going to remove it and then add it back to the set as even. Hopefully by now you've tried to write your own pseudocode for that. So let's take a look at what that pseudocode looks like. So for each element, it's not using a for each loop, but for every element in the set, if it's odd, we want to remove. That's the same code that we just saw up above. And then the only other thing is we have to add it with 1 added. And now I hope you will take attempt to write your own code for this. So let's take a look at what the code selects. So again, we have the same iterator code. While iterator has next, we're going to get the value. If that value is odd, we're going to need to remove it and then add it with 1 added. And I've called input.add here. And some of you may realize there's a problem here, but let's go ahead and run it. So this works fine. That's great. But let me try another case. So let me add one more test case here, and then go back down and run it. And now we get a concurrent modification exception error. So what was happening in this first set of... So the thing about sets is that if the thing is already in the set, it doesn't add a second one, right? So we come in here, we see 1, we're going to remove it, just leaving 2, 3, 4, 5, and then we add 2. But 2 is already there, so we didn't really add anything to the set. Then we take a look at 2. It just passes through. We take a look at 3. We remove it from the set, leaving 2, 4, and 5, and then we add 4. But 4 is already there, so it didn't actually do anything. And that's why we don't get a concurrent modification error, because nothing got modified. The last thing we did was we got 5. We removed it, and we added 6. So that actually adds something. But we never actually went back and got the iter.next. And that's the funny thing about concurrent modification error. Many people don't realize that if you can manage to avoid actually calling next after you remove or add, it will not throw the error because nothing changed before next was called. That is what throws the concurrent modification error. You can see right here in the call stack. So when I added a new set of data that was higher, so this 19, for example, actually adds a new item. As soon as it got to that first one, it crashed. So instead, what do I have to do to avoid crashing? Well, it's because I'm calling input.add. Whenever you use an iterator, you actually have to use the iterators.add. So let's create a new set to be added. Let's put it in that. And what we'll do at the end is that we will then, after we've done all our removes, we can now add all the ones that are to be added. Add all is a function. It's a set operation. It takes everything in this set and then adds it to this set. You could just as easily have just iterated through each of the things in to be added and then done an add to it. But let's go ahead and run that one. And now it works. So remember that when you are using an iterator or a for each loop, if you remove something, it's going to throw a concurrent modification error. But also if you add something, it's going to throw a concurrent modification error. And while you can solve the removal by using an iterator, you cannot solve the adding. So here what I did is I created a second set to hold on to those things, and then I added them at the end. So that's pretty much all there is to sets. Sets have unique values, so when you there's no way to set an item in a set. You can only remove them and add them. And if the thing is already added, then it's not going to do anything. It's not going to add a second copy of it. And of course, the concurrent modification errors mean that you cannot remove without using an iterator. You have to use the iterator's remove. And you also can't add things even using an iterator. You actually need to create a second list set and then add them later. So congratulations, you are now an expert on sets. If you have not done these problems by yourself and said we're just trying to watch along as I did them, that's really not going to help you learn. So please go back and try these problems completely on your own, and that is what is really going to help you learn. If you've liked this video, please like and subscribe. That helps other people find these videos. I am going to be releasing a third tutorial on maps, and I will try to link that in up here as well for you.